you got to figure out some logic. And you have to put some thought into how you're going to operate things. There's one problem where you have grain dryers. So you have a building that supports 4 grain dryers, and then it's got some other stuff in the building like a welder and an air compressor. Now, some of you will say, well, you're never going to operate 4 grain dryers, so, you know, I can have some judgment call on that. Well, yeah, you are. When are you going to operate 4 grain dryers? Harvest. Yeah. When you harvest everything, you're going to dry it all at once. Yeah. Either that or you're going to get mold. Exactly. So I dry them all at once, and something breaks. They're all going dollars to donuts, and something breaks. I got to go turn the welder on, and it's a cold snap, so the heater comes on, and I've got lights on, and the welder comes on. Yeah. So I do run all that stuff at the same time. Not really when you want something to go click. Let's just turn one of the dryers off for a little bit. Then Dad comes in and says, what's the dryer off for? You want the corn to get mold or the peanuts to get mold?
Or the house to be cold.
Yes. Yeah. Or yeah, he'll just turn, he goes, son, turn the heater off and freeze to death, but you're gonna fix that thing. You know how it goes, come on. Yeah, absolutely. So, that's homework problem 1 on chapter 5. Okay, so again, make sure you can read that. In terms of how you would do a test on there, I either put the table in the test so you can read it yourself, or I put the projector on and turn the computer on and actually put it up on the screen. Probably that'd be the easiest thing.
Maybe look up the
Yeah. Or just give you the amperage, you know.
That'd be easier.
Yeah.
Yeah, it would, wouldn't it? Yeah. It's a funny guy there. Now, problem 2, determine the demand load for a milk house with the following loads. Milk house. I had a friend of mine I grew up with up in Ohio a long time ago. His uncle had a dairy, and we'd go hike out back when you could walk around by yourself and not worry about it. 12 years old, you'd walk 5 miles out of town and go to a dairy farm. And the whole idea on a farm was so totally different. They had lunch, 2 grown boys and Dad and Mom and us 2, and they had a platter of sloppy joes. In our house, it'd be like, you get 1. They had a platter stacked like a commercial. And you just picked them out and kept eating them. Like, wow, this is something. And then told one of the older sons, go out and get a pitcher of milk. You just take a stainless steel jug and go out to the barn, dunk it in the tank, you know, whole milk right out of the cow. I mean, it was chilled. It wasn't 104 degrees, you know. Milk's warm, but it was kind of cool. Cool. That's when we played hide and seek and the cows would chase you. I told my dad, I said, God, they chase you in the dark, man. It's scary. He goes, well, stop. What do you mean stop? Then they catch me. He goes, no, they're just curious. They just want to see what you're doing. I'm like, really? But they're so big. They're just a cow. I don't, you know. So anyway, that was my introduction. Oh, well. Anyway. Problem 2, we have a bunch of lighting loads, 10 120 volt lighting and convenience. Again, that's not 10,120. A 5 horsepower vacuum pump. Now, what's the vacuum pump for these days in a milking parlor? Right, automatic milkers, man. That old movie thing where they're underneath the pail, man, that went away a long time ago. Now what do they do? What's the advancing on that milking, on that vacuum pump? What's the next current advancement in that technology?
Hydraulic.
Variable speed drive. Because depending on the attachment to the cows, how many cows are going, what's happening with the, you know, different cycles on that, there's a variable different demand on that motor. And so rather than have it run at 5 horsepower all the time and waste a lot of power, it basically runs the pump to keep a certain pressure in the line rather than just full on. save about half the electricity doing that. About half. So variable speed drive on that's pretty neat. Then they have a 1 horsepower transfer pump, a 4 kW heater, a 1.5 kW refrigerator, funny way to put that, 1/3 horsepower of vent fans, and then we're going to put a little 2 there, let's see, I'm missing a 1/3 horsepower agitator, and they also put a 3 horsepower, I can't remember what that was back there. Compressor. Okay, take a look at that list right there. You're in a milking parlor. You've never been in a milking parlor before. Obviously, most of us haven't. But you can, by logic, figure out that, well, my lighting and convenience, they've got the 50% factor on that, so that decision's taken care of for me. The vacuum pump, the transfer pump, am I going to run those at the same time?
Yes.
Yeah. KW heater, 4 KW heater? Yeah, why not? It could happen, especially if I'm in Wisconsin, you know, or something, or Minnesota. The refrigerator is going to be on. It's plugged in the wall. You don't know if the compressor is going to be on, but it could come on right in the middle of the operation. Your vent fans.
Yes.
Yes, but will they come on the same time as the heater?
I think it's a water heater. Yeah,
Was it a water
It's
heater?
a water heater.
Yeah.
Sorry.
Yeah, it is a water heater.
Yeah. Okay, agitator and compressor. Yeah, they could all happen at the same time. I screwed that up, but I'll show you which way I did it, so we can argue about that later.
Wait, before you continue, let's say that was a heater, and
Yeah.
they had vent fans, couldn't they both come on?
Most likely not. In the coldest part, you could argue about that, but
Because isn't the vent fans there to
vent out the ammonia and all that
Yeah.
kind of stuff? Could be. Good call. I like that. What's in cow manure and urine?
Yeah,
Some ammonia, man. Big time ammonia. You go back to the British Armed Forces, back when they were the British Empire and went all over the world, they came up with a new shell casing, and it's called Admiralty brass. And it was, because the Navy went everywhere, and they took the Marines with them, so they'd go and invade someplace. And they came up with a new brass because the previous shell casings, you put in boxes on the back of mules. And the mules do what they do, and they go where they go. And the fumes that come off of that, the ammonia, the previous brass, it gave them stress corrosion cracking in the shell casing. And so you get in there and fire the thing, gonna blow up, It's like, oh, bummer, dude. What's wrong with these shells? So they came up with a whole new brass just because they're mostly carried by mules. Weird story. So this is where you make those decisions right at the beginning. And obviously right now we've got better information from the class thinking about it than I did. Excellent.
If we're on a test and we make a decision wrong here, are we gonna get the whole question?
Oh, no, geez, you think I lost my mind here? I mean, and they're assumptions, if you state your assumptions, I have to at least consider that. It says you thought about it. So if I can tell what you did, and you had an assumption, that's good news. It's this mysterious calculator. Well, I put in my calculator. Did you write it down? No. Well, how do I know what you did? Okay, so again, anyway. So if I go through this, the same thing, I've got 10 lighting, so VA is 1800 volt amps, and this would be 900 WP. 5 horsepower pump, if you go back in that table for 5 horsepower, you end up with 28 amps for 5 horsepower. So 28 times 240 times 1.25. Again, if you didn't put the 1.25 on there, that's also correct. It's just me being paranoid. 8,400 volt amps and 8,400 volt amps. The 1 horsepower, back to the same problem earlier, was 8 amps, so that was back to 1920. It's no longer the largest pump, so I didn't, or motor, so I didn't add on the 25%. 20. The heater, KW is 4,000. Volt amps, 4,000 volt amps. 1.5 kW refrigerator, 1,500. 1,500, so some of this is just making a list. Your 1/3 horsepower is 3.6 amps from the same table that Ashley quoted earlier, 8.3. So that's 3.6 amps times 240 volts, which gives you 864 times 2, because there's 2 of these. Oh, no. Yeah, 1720. And this is the part where I messed up. The vent fans could come on at the same time. I didn't put that in. The 1/3 horsepower agitator is 864, and then this is 864. 3 horsepower was 17 amps, and 17 times 240 is 4,080 volt amps, 4,080 volt amps. So again, you're in the same process we did on the last problem. You add these up, divide by 240, get your 2 different amperages, then you take 100% of the largest load, which is the load without diversity. Largest motor, which is 8,400, which is 35 amps, which is not anywhere near the 90 plus amps you get, or a 60 amp minimum on the building. So you go through that, and I ended up with around 96 amps for that, but I guess that would be a little low, because I should have done that. So, now, problem 3 was the one with the buildings everywhere. You know, and it had the little X where it was, and all this kind of stuff. Most of us got that. I had a couple that were curiously way off. And all I can think of is we just missed a dimension, or missed whatever, but is the sum of the loads was equal to 50 amps for one building, plus a 75 amps, just some of the loads, 75 amps for the other, plus 120 amps, plus 160 amps, plus 15 amps. So you end up with 420 amps of the sum of the loads. Then if you go in and do sum of the X divide times L divide, we get the 50 amps times 100 feet, plus 75 amps times 100 feet, plus 120 amps times 250 feet, plus 160